Hello students, today's topic is force. Now we have started force and laws of motion. But first of all we have to now discuss how many types of forces are there. So basically we classify force into contact force and non-contact force. Contact force is that when we have to physically touch something to cause motion or to stop motion. Now for example, this is oscillating like this. I want to stop it. If I say stop it, stop, it is not going to stop. I have to touch, apply force and then it will stop. And if I have to bring it into motion, okay, move, no, I have to touch. So this is an example of contact force. Various contact forces are there, some of which are air resistance, which we also call drag, then water resistance, muscular force and then tension. Now what is tension? Now if something is suspended from a rigid support, then two forces are acting. One is the force of gravity called weight of the object pulling it downwards. But it is not falling down. Why? Because there is an upward force acting on the bar with the help of this string, and that force is called tension force. Tension due to string. Now when we talk about non-contact forces, right? Non-contact forces are the forces which act from a distance. For example, these are the iron fillings and the magnet. And see, the magnet is at a distance and still it can exert force. Right? So, magnetic force, electrostatic force. Now see this chalk. Right? Now I am holding it, I am applying force against gravity. If I stop applying force, then it falls down. So this force is acting from a distance, gravitational force. So this is a non-contact force. But what about balanced and unbalanced force? We have not discussed it because it is not that a particular force is balanced and other is unbalanced. It is a condition. It depends upon the situation under which there is interaction between two or more forces, and at that time the force may become a balanced force or an unbalanced force. Now see how it happens. Now if there is a trolley lying here, you are applying effort of 10 Newton and you see that the trolley does not move. Now why so? Why the trolley is not moving? You are applying external force. It means there must be some external force which is opposing this force. So that is the force of friction. So the force of friction is opposing the effort, right? Now what happens? One force is acting from left to right, other is acting from right to left. Then what is the net resultant force? So resultant force is the overall result of various forces which are acting on an object. Now, if it is 0, then there will be no motion. If the resultant is 0. Now how to find resultant? By addition. But forces, can be added by vector sum, which is beyond the scope of your syllabus. So here I will tell you to find F net or the resultant force, just you have to do is subtract bigger force. You take bigger force and subtract smaller force from this. When we look at this case, that on applying effort of 10 Newton, it is not moving. It means that the frictional force is also same. Now there is no big, no small. So the two forces, F1 minus frictional force comes equal to 0. So F net force acting on this is 0. So there is no external unbalanced force which is the resultant force. It is not there. Why? Because it simply got cancelled. Right? So net force is 0, and we have already discussed when there is no force acting on the object, then the object will retain its state. It will maintain its state. If it is at rest, it will remain at rest. Okay? So now, what we are going to do now is, we saw that both the forces were same. So the forces were balanced. Net resultant force was 0 and doesn't change the state. Now the states are basically two, rest and motion. So if this was at rest, so it remained at rest. Now we take another example that it is moving with a velocity 20 meter per second. Now it is already moving with this motion, right? It is already having a velocity of 20 meter per second. The force is applied by the engine and the frictional force is being balanced and the car is moving. So till the time we do not change this velocity, right? Either we decrease or we increase, then we do not have to apply any external force. At that time, the force acting is a balanced force. The balanced force is the force applied by the engine and the force applied by friction are balanced, and the extra force which is there, that is pushing it, and if we do not want to change its speed, then it will go on moving without applying force. Again see, let us say engine is applying now 20 Newton. Now the frictional force we said was 10 Newton. Now out of 20 Newton, 10 Newton is balancing it and the rest 10 Newton is pushing it forward with this velocity. Right? Now, in this situation, when it is moving with a velocity of 20 meter per second, we need not apply any more external force. Okay? So, a balanced force does not change the state. If the object was at rest, it will remain at rest. And if it is in uniform motion. Which motion? Uniform motion. Okay? That is, the velocity is not changing. There is no increase or decrease, then the forces are balanced. Okay? I hope the balanced forces are clear. So if they do not change speed, they do not change the direction, then what is the effect? These forces, balanced forces, can change the shape or size. Right? See. Now its size has reduced by applying forces, but I am applying equal forces from both the hands. When I release, when I stop, then it comes to its original size. Okay? Now you see this rubber band. If I apply an external force, I can change its size. Then it comes back to original size, but it is not moving from its position. So, in the first video, I discussed 5 cases with you when the body is changing its state from rest to motion, motion to rest, speeding up, speeding down, or changing the direction. So the 6th is change in shape or size due to a force, and that force is a balanced force. Now why it is balanced? Because the situation is such. Situation is such that I am applying equal forces from both sides. Now Let us consider another example in which the body was moving with a velocity of 20 meter per second. Now, u20, we want to increase the speed, right? And direction is remaining same. So, there are two things, speed and direction. Even if one is changing, velocity is changing. So, I want to increase the velocity from 20 to 40. Now, I have to change the force from 10 Newton to 20 Newton. The force after cancelling friction should be 10 Newton. That is, it should be 30 Newton. 20 Newton plus 10 Newton. Now 10 Newton and 10 Newton are cancelling, right? And the 20 Newton is now the unbalanced force. Understood? Let me tell you again. Total effort 30 Newton. Frictional force 10 Newton. So 10 Newton out of 30 Newton is cancelling friction. The rest 20 Newton is changing the velocity from 20 meter per second to 40 meter per second. So unbalanced force is that force when the net resultant force is non-zero. That is, when two or more forces are acting on an object and the net resultant force is non-zero, forces are unbalanced. And unbalanced force always changes the state. That is, it can make a body move from rest to motion, or it can make a body stop from motion to rest, or it can help in changing the direction of motion. Now, another important force which is very useful in our life is frictional force, right? We cannot work without friction. We cannot hold chalk without friction. We can't write on the board without friction. So frictional force is a contact force. It comes into play when two objects are in contact, right? And the object tends to move. When the car is here, okay, the friction is there. When I apply force, then frictional force is also exerted. Now I am applying force from left to right. So frictional force is acting from left to right. In your NCERT you have an example also. So let us say I am applying force, but it is not moving. It means the frictional force is equivalent to the effort applied. I increase effort. Still it is not moving. It means friction has also increased. I increase the effort more. Now it starts moving. What does it mean? That friction is a self-adjusting force. How self-adjusting? When I applied only 20 Newton, it can move with speed of 20 meter per second, because 10 Newton cancelled the friction. I increased force, then speed increased. But if I apply only 10 Newton, as we discussed in the first case, then there is no movement. Okay? Then we increase the force from 10 Newton to 15 Newton. Even then it doesn't move. It means friction has also increased from 10 to 15. Okay? And then what we do? We further increase from 15 to 20. Now what happens? That the object starts moving. It means friction is able to adjust, self-adjust up to certain limit. So that is all about balanced and unbalanced forces. Thank you so much.